In this question, we're exploring the different ways of representing bearings. It asks us to draw some diagrams of some different bearings. The first two examples are what we call true bearings. With a true bearing, or sometimes called a three-figure bearing, it's always done as the number of degrees of clockwise rotation from north. So in this first case, 105 degrees true means from north, rotate in a clockwise direction 105 degrees. Now if I was to rotate around that much, that's rotated 90 degrees from north. So it's 105 is going to be a bit more than 90 degrees. If I was to draw a line down there, somewhere heading out in that direction, that would be more than 90, so it probably could be about 105 degrees. If you drew it like that, so that was 105 degrees, then that angle heading out in that direction could be an angle of 105 true. An angle of 207 true is going to mean, well, from north, clockwise rotate 207 degrees. So round to east is 90, round to south is 180. If I go right around to west, that's another 90, that's 270, so I've gone too far. So it's a bit past 180. If I put an angle out here, so that that whole angle was 207 degrees, that's all that we have to do. The next one is giving them as reduced bearings. Now reduced bearings reduce big angles like this, and they write it in simpler terms so that you've always got an acute angle here. You've always got an angle of less than 90 degrees in the middle of a reduced bearing. Reduced bearings by convention start with south or north and end in east or west. So south 20 west means starting from the south, rotate 20 degrees towards the west. Starting from the south, rotate 20 degrees towards the west. It could be something like that. Or north 82 towards the west means start from the north and rotate towards the direction of west for 82 degrees. 82 degrees was getting on for 90, isn't it? So better make it look like about 82 degrees. So that could be the bearing north, rotate 82 degrees towards the west. Okay, down the bottom of the page, we're asked to give each of these diagrams and give the bearing in each in two different ways. So we're going to give it as a true bearing and also as a reduced bearing. Now for true bearing for the first, I want the number of degrees rotation from north. So it would be 180 around to here, but it's gone further. It's gone another 65 more than 180. 180 plus 65 equals 245 degrees of clockwise rotation from north. We could write that as 245 degrees true. Now there's another way we can write it too, using reduced bearings. And to use reduced bearings, we'll either start from north or south. Well, I'm going to start this one from south and rotate it 65 degrees towards the west. So I could write it like this. Start from south, rotate 65 degrees towards the west. Now the next one here is a little bit tricky. Starting from north, I've got to rotate so many degrees. So how many degrees from north am I going to rotate? Well, if I went all the way around to east, that would be 90. The direction I'm looking at here is 28 degrees less than that. So it'll be 90 minus 28. 90 minus 28 is 62. So this angle in here would be 62. And so that's the number of degrees clockwise from north that I rotate to get to that bearing. So I could write this as 62 degrees true. Now they're sometimes called three-figure bearings, and normally if they're an angle which is less than 100, you normally fill up that and call it 062 degrees true. If I want to write this one as a reduced bearing, I would say from the north rotate 62 degrees towards the east. Now some people say that it's okay to say, well, this could be starting from east, rotate 28 degrees towards the north. Now that is okay, they've made no mistakes there, but it's a bit unconventional. The convention in maths is either to start with north or south and then finish in either east or west. Okay, let's look at the next one. Remember, for a true bearing, it's the number of clockwise degrees from north. So we've got to work out how far the rotation is all the way around there. For this one, what I'm thinking is, well, if I did a full rotation, I've done 360 degrees, but I'm going to stop 45 degrees less than that. So 360, take away 45 degrees, equals 315 degrees clockwise from north. Yes, that is right. Okay, now to give that as a reduced bearing, remember, start with either north or south, finish with either east or west. Starting from north, rotate 45 degrees towards the west. North, 45 degrees west. And the last one here, how many degrees from north would I rotate? Well, starting from north, I've got to go all the way around to here. It's 90 degrees to the east, plus another 30 more. That makes 120 degrees in all. 120 degrees from true north. Alternatively, I could give this one, and I've got to give it as starting from north or south, and that angle in the middle of a true bearing has to be less than 90 degrees. So there's only one way I can do it properly, and that's to start from south and rotate. How many degrees will it be around till I get to that line? Well, it's 30 degrees there. Together they make 90. So south 60 degrees towards the east as a reduced bearing.